Welcome to lesson 2.7. This is the last lesson of the chapter. So after this lesson, we'll do the practice next week, obviously. We're doing the notes today. That'll be it. And then we'll start doing some review for chapter 2 test. So let's jump into this. Now we're looking at systems of equations that involve linear and quadratic functions. So how many does this system have? The amount of solutions it has is how many places the line and the parabola intersect. So if you look at the graph of this one in particular, it's crossing twice, so the system has two solutions. How does modifying the linear function affect the number of solutions? So the b would be the y-intercept here. So if I slide, you can do this on your own as well, but if you slide it up, it's obviously crossing twice. When the y-intercept is exactly -1, it's touching it exactly once. That's called a tangent. We'll get into that more when we get into trig stuff, but that means it's touching it once. So there's going to be one solution. Anywhere lower, that line's never going to touch that parabola. So there's going to be no solution. So the possibilities for a quadratic linear system is there could be 0, there could be 1, or there could be 2 solutions. It'll never cross, a line will never cross a parabola more than twice. So the options are 0, 1, or 2. Let's look at this one. It says, basically it's the same type of thing. It's you got a quadratic equation and a linear equation. Determine the number of real solutions. So it's not even asking what are the solutions, just how many. We're going to figure that out by graphing it. That's the best way to do it. I'm going to open up my calculator here. I'm using the Desmos one now because my other calculator expired. Anyway. All right, so we're going to, I forget what it was, 3x squared. All right, 3x. All right, so that's your parabola. And then the second one was 3x minus 2. All right, so 3x minus 2. Clearly, that line is not crossing the parabola, and it never will. So as you move out to the right, the gap's going to get wider. And the same with the left, actually. So this system has no solution. Okay, let's look at example 2.